All right, good evening, all of you out there in Algebra 2 land, you lucky ducks. We get to learn about radical notation for nth roots this evening. Now, in our power chapter, we actually saw a lot of these, but we didn't work too much with converting them back and forth. So first thing you'll want to write down is your definition here. And your definition says, for any non-negative real number x and any integer n being bigger than or equal to 2, that's all mumbo jumbo. The important stuff is right here. We know that the nth root of x is equal to x to the 1/nth power. So these things are one and the same. So remember, the nth root of x is how you read this, and this is x to the 1/nth power. Okay. So for example, if we had 3 as our n, we would have the cube root of x, or the third root of x, however you want to say it, is equal to x to the 1/3 power. So these two things are equivalent. We just have a new notation for them. This, remember, well, it's actually the title of the chapter, so I hope you remember, is called your radical notation. Radical notation. And then this guy was the old stuff, so this is power notation. Whoops, power notation. All right, and this section is going to kind of focus on going back and forth from one to the other. Okay, so let's take a look at our first example here on the next slide. Okay, example 1 simply says evaluate the fourth root of 81. So we're going to do the fourth root of 81. Now this is pretty easy. You could, if you wanted to, change this to power notation. It'd be 81 to the 1/4 power, and then do it in your calculator. But we can actually do both of these, and I want you to do both ways in your calculator to learn something new today. Okay, so follow along and really get out your calculator. Alrighty, because you need to know how to do this. So we're going to grab ours here and turn it on. Let's see what kind of mumbo jumbo we got left. Alright, so we're going to do them both ways. Now we already know how to do it this way. This is probably the way you're used to. So we do 81 to the 1/4 power, of course putting that 1/4 in parentheses, and we hit enter. Boom, we get 3. So that's our answer. Or we could do it the new way rather. So then that would be putting this into your calculator. So the fourth root of 81. Now you have to be very careful when you do this. You have to put the 4 in first. So your root goes in first. You cannot use the square root sign here. You have to go into your math menu. Okay? The only option that's going to work for you is this number 5, which has a little x right here. That's saying, well, let's grab it first. So number 5, whoops, you can hit 5 if you want to as well. So that's saying take whatever you put first and put it where this x is, which is really where this 4 is here. So this is saying take the fourth root of whatever I'm going to put next. Please make sure that you don't use the square root, which is out here in yellow. You have to go into your math menu to find that. So we say enter, and boom, we still get 3. Just to illustrate why the square root doesn't work, if I use that button, let's try it. Boom, 36. 3 and 36 are not the same number. So the 3 is what we want. Alrighty? So you have to go into that math menu and choose number 5 there. So we can actually maybe even jot that down. Okay, so to do it this way, put in 4 and then go to math. And then number 5, which looks like this, a little x with the square root symbol, and then you put in 81. Okay, so that's how that step works. You already know how to do it this way, so I'm not going to bother writing that down. So at any rate, we could say fourth root of 81 is 3, because that's our answer. Alrighty, estimate the fifth root of 4.2 to the nearest hundredth. So it's going to give us a decimal here. So let's do the fifth root of 4.2. I'm going to go ahead and write it as 4.2 to the 1/5 power. It's the same thing. And now, since we just learned this way of entering it into our calculator, let's do it that way. Okay? Could you do it this way? Sure. But I'm going to do it the new way. So let's turn this back on and clear it out. And we're going to do 5 first, and then I go to math menu, choose number 5, so I can just hit the number 5 if I want instead, and then I put what I'm trying to take the fifth root of, which is 4.2. Enter. Okay, 1.3, now we want hundredths, so that's 2 places. So 3, we look over, we don't round up, so it's 1.33. So 1.33 is the fifth root of 4.2. Okay. These are easy enough so far. Let's see what else we got. Oh, another theorem. Okay. It's the root of a power theorem. It says for all positive integers, m being bigger than 1 and n being greater than or equal to 2, and all non-negative real numbers, for x, we know if we take the nth root of x to the mth power, it's getting sticky here, but hey, bear with me, equals the nth root of x to the mth power, or x to the m over nth power. Okay, so there's now 3 different ways we can write these. Let's take a look at examples, because sometimes it's just easier to see with numbers here. So this is purely radical notation. Notation, which is kind of what's new to us in this section here. And this is saying take the cube root of x to the fifth, so maybe we can put that down here. Cube root of x to the fifth power That's what this says. Take the cube root of x to the fifth power. So you take the x to the fifth power first, then take the cube root of it. That's different from this. Now this is still technically, I guess, radical notation, although, yeah, it is. It's just written a little bit differently. So this one says that you're going to take the cube root of x and then comma, then take it to the fifth power. So here you're going to do the cube root first and then take it to the fifth power. These are kind of the same here, except notice we put the 5 on the outside, so the cube root's coming first this time. And then this guy, we're back to power notation here. And this is just simply x to the 5/3 power. Okay, and that's power notation. Okay. So 3 separate ways to write these. And one is not better than the other. Some people are more comfortable with radical notation. Some people are comfortable with power notation. And in certain problems, you're going to find one is easier than the other. So you should be able to translate between all 3 of these different types of notation here. Okay. So it says, suppose x is greater than or equal to 0. So we're working only with the positives. So we're going to simplify the cube root of x to the 12th. So let's start practicing our translation here. So third root of x to the 12th power. We can translate that into power notation. If you want, we can do it one step at a time. Let's write it as the cube root of x and take the 12th on the outside. You don't need to do this step. This is kind of like a preliminary step here. But essentially, you're taking x to the 1/3 power, because that's what cube rooting is, remember, to the 12th. Okay, and then, okay, well, I have a power to a power, so I multiply those. How do we multiply fractions? Well, we multiply their numerators. So I'm going to go down here. And so 1 times 12 is 12 over, and then we multiply their denominators. So 3 times 1 is 3, so 12/3. Now notice, all I did is I had x to the 12th, so 12 goes on top, and the cube root, the cube goes on the bottom. So you can remember that by, it has to be 1/3 somehow, so the 3 has to be on the bottom. Right, so you just take the power on top, the cube, or the root, excuse me, on the bottom, because it won't always be a 3. Alrighty, now if you can, notice 12/3 actually does simplify, so 12 divided by 3 is really just x to the 4th power. So we were doing a little bit too much right here. That's why they wanted us to simplify it. Simply all we had to do is take it to the 4th power, and that's all we needed. We didn't need to take it to the 12th and then cube rooted it, because that would be the same thing as taking it to the 4th. Okie dokie. Suppose x is greater than or equal to 0. Rewrite the square root of x, and no, that's not a typo, using rational exponents. Is this expression an nth root of x? Justify your answer. Okie dokie. So we're going to take this one step at a time. I know it's incredibly odd to look at, but let's write it out. We have the square root, the square root, the square root of x. So I'm going to start with this little baby square root here on the inside. I know if I square root it, remember there's an imaginary 2 right here. Oops, sorry. An imaginary 2. So I could rewrite that as x to the 1/2 power. Okay? So x to the 1/2 power is all I'm replacing here. And then I still have 2 more square roots left to deal with. Okay? I just replaced this guy with x to the 1/2. Now, this, again, is another square root, so it's another half. So what I have here is I have this original x to the 1/2 to the 1/2. Yikes. And then I still have this big square root on the outside. And you guessed it, this is another square root, so it's another 1/2. So we have x to the 1/2, this is the original one. And then to the 1/2, this was the second square root. And then to the 1/2 again. And now we have all 3. Notice we had 1, 2, 3 square root things to start with. We have 1, 2, 3 1/2 powers to end with. So let's go up here. And we have x to the 1/2 to the 1/2 to the 1/2. We have a power to a power to a power, which means I need to take 1/2 times itself 3 times. So 1/2 times 1/2 is 1/4. 1/4 times another 1/2 is 1/8. So that would give us x to the 1/8 power. Yikes. Which, is okay. 1/8 is not bad. This looks honestly scarier to me than x to the 1/8 power. So then we want to know, okay, so we rewrote it using rational exponents. Is this expression an nth root of x? Well, could we rewrite it back as using one of these? Now, if I only wanted 1, what number would I have to put here? Well, x to the 1/8 power is equivalent to taking the 8th root of x. So you would say, yes, it is an expression because these two things are equivalent. Okay? So we're good. We got it. I know this was scary, but just break it down. It's the square root, so it's a 1/2 power. Those two things are equivalent. Do me a favor, practice one more. I want you to take the 5th root of x to the 7th power and rewrite that using rational exponents. Rational exponents. Alright, I know this wasn't a planned example, but I want you to rewrite using rational exponents on your own, and I will check your answer tomorrow. So this, hopefully it'll take you 2 seconds. Just rewrite using rational exponents, so you're going to have this to some power that's going to be a fraction. Okay? And that's all. So have a great night.